Hello, my name is Joel Niedermeyer. I am in business modeling and analysis. This is my paper on the queuing theory. This is September, October. We are now in October the 20th, and I'm going to start with the points of the abstract of my paper. The queuing theory has a presence in our day-to-day life, sometimes without us even knowing about it. As we drive to work or we go shopping, especially driving to work, we realize that there is bottlenecks in traffic. There's patterns in our traffic flow as we go to the malls, and all of this is part of the queuing process that civil engineers and places like that use to design how these roads are set up. That's why we get 3 lanes instead of 2 lanes, or because of the additional traffic that's involved. When you stop in and order fast food in a fast food chain and wait to be served, the queuing is part of our human patterns in those highly studied in the fast food chains. This paper will further discuss the formulas as well as the theories of the queuing theory. The queuing theory originally is the study of the customer waiting process in a mathematical format prior to getting service in any manner. This mathematical process is used to decrease the waiting periods of the customer and to have better efficiency with the company. The theory is used for many reasons. In some instances, the formula uses customers instead of packets, or in any item that has a known waiting time to calculate. So in what I'm kind of referring to in mine would be the people, the customers are what they're saying is the packet. As you read through some of the information that I've seen, they always talk about the calculations are per packet and how long the packet is here and packet is there. But for the moment, we're going to just talk about customers. The search was conducted to explain the first known queuing research was conducted by Anger K-R-A-R-U-P Ingerloh in 1909. The research was conducted to explain the waiting times of incoming calls into the Copenhagen telephone exchange. The model queuing is designed around the point of a customer's arrival. The model of queuing is designed around the point of a customer's arrival, with the number being in units of time, addition to the number of people served and the delay time before each one is served. So basically, is how many calls came in, how many calls can they answer in a certain period of time. The average is used to design ways to serve more customers at the same time. The process of queuing is a well-studied theory that can save time and money in many applications, such as providing improved traffic flows, as we mentioned earlier, also call centers and supply chain management. The more well-known uses of queuing would be in the stock market and EKG machines. The use of systolic processes uses seemingly random data and applies it to an outcome based entirely of time. Discrete and continuous information of finite and countable jobs or instances are used to create a process of tangible data that can be studied to understand queuing and logical applications. One of the forms of calculation that is used with or was derived from is Little's Law, which states for a given arrival rate, the amount of time is proportional to the packet occupancy. And in there is n equals 1 times t. Basically stated, the n is the average number of customers, or in this case packets, and the 1 represents the arrival time, and customers per unit time. And finally, t is the average daily in the system, average delay in the system. The example of this particular equation is the time spent in an amusement park. This is what I kept coming across, is time spent in an amusement park. Customers arrive to the park spend time at the location and events, and leave. Another analogy would be the rush hour traffic, or I mean the rush hour lunch at fast food places, and how fast and how many n number of customers can be served in that specific period of time. To further explain the theory of queuing, we must look at aspects that have effect on the theory, such as what we referred in the beginning, and would be bottlenecks. Bottlenecks are not just in traffic, but also in it's traffic also in the fast food chain itself, with the amount of people coming in. How many people can they serve at a time? The bottlenecks are access points that can have flow controls due to size of area or convergence of operation. As one can imagine, if we overlap a web page with a large, or overload a web page with a large amount of inquiries, we can overload the website and shut it down. That can also be considered a bottleneck. How many people can be in this web page at the same time? Bottlenecks can be explained in a multiple of ways. In a call center applications, the bottleneck may be the amount of phone lines that a company has to serve the customers, or could be amount of people that are working receive the calls. Either way, it is ultimately the slowdown of the operation. The factor is broken down into utilization, and the average and incoming element is slowed down to the final process. In this, with the calculation, they talk about departure time equals average time plus workload found in the system plus transmission time. The company that I referred to in my paper is, just for one instance, was ice machines. I deal in ice machines, lease ice machines, and sell ice machines. I guess I kind of knew this, but to a certain extent, the company has ice bins. The ice machine sits on top of a bin, and the ice goes into that bin, and then you as the customer go and get it out. Well, they have set it up as a first in, first out as part of their queuing standard, to make sure that you're always getting fresh ice. And so this is one of those situations where queuing is every part, many parts of our life. One way or the other, you're involved in it, and you may not even know it. Hoshizaki Ice Machine has ice making equipment. The equipment is designed to keep fresh ice in the bin and give access to fresh ice for the customers. It's known as first in, first out, or product displacement. And this is M/M/1 is a simple process. M divided by M divided by 1 is a simple process to have one server serve one customer, and the first customer is the first to be served in the process. To explain better, the ice from the ice machine is made and drops into the bin and deflects the bin into the bin, and is set in such a way that the ice made prior to this is available to the customer. This process is extrapolated out to accomplish a variety of circumstances that businesses use to accomplish certain problems. Customers such as Hoshizaki design their equipment to allow the product to stay fresh and maintain high standards of ice machine equipment. As we can see, queuing is used in a multiple of applications. Another such company that used queuing process perfect is Panera Bread, and this is the one I've actually done some studies in different aspects of Panera Bread as far as their business modeling and everything else. But their queuing process is one of the best that I've seen. I mean, I think it's one of the ones that represents how they've taken queuing to the next level in some of the newer Panera Bread locations. Panera Bread has implemented a new model, M/M/C. This model went from having a server that handled coffee or meals to having the server able to handle any order. Their company has gone to add other stations that allow the customer to make and pay for their own orders without going up. To keep it spreads them out to alleviate bottlenecking. Once the order has been placed, a locator is issued for the server to deliver your order to the table that you have chosen. Once in the queue, the customer can use the free Wi-Fi that is offered to do homework, or just surf the web to allow pass the time. Basically, when you get in the queue in a Panera Bread, you can utilize their Wi-Fi and to pass the time while you're in the queue, as opposed to most places where you just kind of sit and wait and listen to the boring music. But in this case, they give you a little bit more availability for things to do while you're waiting for it. These order stations reduce the bottlenecks during rush hour and lunch hour lunch hour dinners and stuff. It reduces the wait times and it also allows them to increase their traffic, which increases profit across the board. What is the cost of long wait times and equipment that does not provide fresh product? The answer is pretty easy. The answer is loss of customers and capital. The properties that we have explained so far contain information we call stochastic processes, which are random values such as x, and it is multiplied to a moment in time such as x. Markov process, which you see quite a bit when you start referring to the queuing theory, which is another state, uses such values to gain insight on factors that concern the system that we are working with. The process xt can be viewed in different ways. Markov uses the memoryless properties as the state of function at some future point, such as t times n plus 1. Markov theory or memoryless states gives no bearing to the past history, such as future and some future points, such as Markov's theory of memory states gives no bearing to the past history of the system, only the future. Markov process can be simplified in two parts. The state of nature that are being calculated are a finite number, and transition probabilities that are intermingling between the states are used. The state of these probabilities, for example, may be the weather or how it could change from raining to the temperature, or the direction or the snow. Markov process can also be explained through the emotions that a person has in one day. The process transitions within the period. All the previous mentioned factors, including others, are used to obtain response, server utilizations, queue lengths, and queue calculations are also used to analyze standard queuing messages. That's pretty much it. I appreciate the class. I did very much enjoy it. I found it very challenging. If you would have a good day, I appreciate it.